All right, this is the last example from chapter 4. It is the amount of energy needed to assemble a group of charge. Now, before I tackle the question I want to do, which is question 69, I want to talk about question 49. So in the slide, you have question 49, and it is example 7.3 from the OpenStax University Physics Volume 2. Now, reminder, I don't talk much about that book, but it is free. It is online on openstax.com. Now, the reason I'm mentioning this is question 49 is a good example. It's a very long example though, and I don't have enough space on my board to do it, so I decided to tackle question 69, and you have the complete solution in the OpenStax textbook if you need some more practice. All right, that being said, let's switch to question 69. Okay, question 69. Find the amount of work an external agent must do in assembling the three charges in the figure, starting each charge from infinity. So what you're shown in the figure is three charge. Q1, well, it's not named Q1, but we are going to denote the first one as Q1. 1 microcoulomb at the top left. The bottom one is minus 2 microcoulomb, denoted Q2. And the third and last charge, Q3, which is 3 microcoulomb. So from what you have seen from the slide, when we want to determine the amount of work needed, we take each charge individually and we bring it from infinity to a point. So this will be done in 3 steps. We will bring charge Q1 at the beginning, then charge Q2, and then charge Q3. Okay, so let's start with the first step. There's no charge, and we're taking Q1 from infinity and we're bringing it at a certain point over here. Now there's no other charge, so to fight the displacement of the first charge, that means there's no work needed here. The total amount of work is 0. In some sense, it's like you're using the potential energy formula and one of the charges is 0. Well, there's no charge, so one of the charge really is 0. Okay, so the second step, we are going to bring Q2. So we are coming from infinity and bringing Q2 at this point 3 meters away from the first charge. So we need to calculate the electric potential energy. So it's Coulomb constant multiplied by Q1 multiplied by Q2 divided by the distance, it's 3 meters, and we get minus 0.006 joule. Note, it's minus because this one is minus. An important point also, if both of them were minus, this term will be positive. It makes sense. If they're both minus, you will need to apply a force to get them closer together. Actually, in this case, you would need a force to slow them, to prevent them from colliding toward each other. All right, so we got this step. Now the last step, we bring the third charge from infinity at this point. Now the third charge has to fight the electric force of both the positive charge Q1 and negative charge Q2. So it's the same logic here. We have to calculate the electric potential energy in this case, and we calculate the electric potential energy against the first charge. Now note, just as in our previous example, the distance between the first charge and the third charge is 5 meters, because you would create a triangle with a side of 4 meters and 3 meters. The distance between Q1 and Q3 will be the hypotenuse, therefore a distance of 5 meters. All right, so 5 meters over here. Note, I added, and this is just because otherwise I will need an extra step over here. The second potential energy, I added a minus and an absolute value for the charge. It's just because this charge is negative, Q2 is negative, and Q3 is positive. So this term will be negative, and I just did not want to erase everything and restart. It made more sense. It's easier to write that way. So we have a minus over here. We compute the value and we end up with minus 0.0081 joule. And actually, I will still need to erase everything because the question is asking the total energy. So that means we need to add the first step, second step, and third step to get to this point. If you need to pause the video now, I'm gonna erase the top part. So the total work, and my marker just gave out. So the total work has to be the potential energy of the first step. I'm gonna name it uppercase U1, plus the second step, plus the third step. and we have 0 minus 0.006 joule minus 0.0081 joule over here, and we get minus 0.0141 joule. That's the total amount of energy needed to assemble these three charges. All right. So concerning that section of chapter 4, it is possible that you get a similar question in a test, but it won't get much more fancy. So if you are able to do this one from beginning to end without looking at your note, you're in good shape. All right. I will be probably more creative with the remaining of the session though, so make sure you study properly. Now we are done with chapter 4. Everything we've seen from chapter 1 to chapter 4 will be included in the first test. Make sure you understand all the example, and for sure I will repeat that part in the course itself. So, all right, see you in the next chapter, in the next video.